All right, let's look at the last part. I'm going to revolve the region R3 about y equals 1 line. Okay, R3 is the light blue region, and an axis of revolution is right here. Okay, let me just get a cleaner picture here. So here we go. So we have more space now. Okay, so we're going to revolve everything around y equals 1 line. And we're going to use the washer method, so that means we're going to take a slice perp to y equals 1. So we're going to get like vertical slice, a vertical slice. And that's going to come with thickness dx. Okay. And after the revolution, it's going to look like this, right? Okay, something like this with thickness dx. So all we need is the inner and outer radii. Okay, so let's see what we have here. So this whole thing here is the outer radius. And starting from right here, all the way up here is the little r. Okay, let me just clean the washer so we can actually work through that better. Okay. And as I said, the thickness is dx, and let's say like this is x units far from the y-axis. Okay. All right. So the outer radius is so like easier to determine because it's going to be just 1. Outer radius is just like the distance from the x-axis to the y equals 1 horizontal line. That's just 1. The inner radius is that total distance minus this distance here. Okay, let me just use a color. So whatever that distance is, I'm going to subtract it from 1, and that's going to be a little r. Okay? There we go. So that is determined by blue curve because the top part of the slice is touching the blue curve, which is y equals x squared. So that tells me that this is just x squared. So little r, for that reason, let me just write here, little r is going to be 1 minus x squared, whereas capital R is going to be just 1. Okay? And the volume of that representative washer is going to be pi r squared minus little r squared dx. So that makes it r 1 squared minus 1 minus x squared dx. All right, so all the x's in the light blue region are ranging in between 0 and 1. So I can go ahead and write down the volume of that region. So volume. The volume is pi times integral from 0 to 1. Okay. 1 squared minus 1 minus x squared dx. All right. So let's expand everything out. 1 minus 2x squared plus x to the 4th dx. And this is already 1, by the way, so just 1. Okay, so 1's canceled, and then you have 2x squared minus x to the 4th left. Let's integrate everything in one shot. 2x cubed over 3 minus x to the 5th divided by 5. And this is from 0 to 1. Let's plug in the upper limits. So pi 2 over 3, 1 over 5. And if you plug in the lower limit, you just get 0, right? And all in all, if you simplify that, you have 7 pi over 15. Okay? So the volume of revolving the light blue region right here, light blue region about the y equals 1 vertical line is going to come with a volume of 7 pi over 15. All right, I think we're all done with all parts of this exercise. This was a very long exercise, but we had the chance to practice the disk and washer methods separately, and the axis of revolutions, the axes of revolutions were sort of like different in each case. In some cases, we had the vertical, and in other cases, we had the horizontal type axes of revolution. So this is a good practice problem for you from your end to to uh, to practice. In fact, all different cases in one simple graph here. Okay, you can in fact make up some more by yourself. Let's say like in part one we had R1 about x equals 1. You can go ahead and R1 about y-axis, R1 about x-axis, right? Um, or R2 about y equals 1 was the one that we attacked in part 2, but you can do R2 about x-axis or R2 about y-axis. So you can actually get a lot of different combinations in this example for your own reference, okay? So you can practice more by yourself. All right. Thanks for watching. This was a long video. I'm sorry about it. I will probably see you in another video. Bye.